thanks very much for joining us today for our webinar, Design for Manufacturability with SolidWorks. My name is Neeta Sharma. I am an account manager here at Javelin Technologies. My co-host this morning and the person who will be doing all of the demonstration stuff is Michel Cloutier, who's with SolidWorks, and we'll introduce him in a few minutes. So again, thanks so much, and we'll get going. So today, the topics that we're going to be covering are four main things in terms of SolidWorks and manufacturability. How can you control your manufacturing costs? How can you reduce any rework that on documents and files that go to the shop floor? We're going to talk a little bit about how you can minimize costly production errors, and also how you can easily transition from your current software, whatever it is, to SolidWorks. Just a quick thing on Javelin and our training program. We've got some AEs here. We've got some really talented people and some talented resources. We have a whole team of applications engineers who split their time between instruction and answering your calls when you do call in for any technical support needs that you might have. We've got multiple certifications with all of our applications engineers, and as it stands currently, Javelin Technologies has an elite applications engineer. There are only a handful of those worldwide with SolidWorks, so we're really, really lucky and quite proud to have, you know, one of these guys on our team as well. So basically the bottom line on this is if you need any technical resources at all, again, whether it be on tech support or whether it be with training, we've got a very, very highly certified staff and people that can certainly answer any questions that you might have in regards to SolidWorks and how it works. Michel Cloutier, he is going to be doing the technical demonstration this morning. He graduated from college to Sherbrooke. He's been a designer, he's been a quality assurance person, he's been a trainer, and he's been working with us here at Javelin for about 3 years since he started his career with SolidWorks. He's got great experience. He's been in the field for over 12 years, so he knows the ins and outs of not just SolidWorks, but how it can compare to some other products that are out there right now. And his official title is Application Specialist with SolidWorks, and he's been, like I said, helping us for over 3 years. And again, we're really happy and really proud to have him with us. So thanks again very much for joining us today, and I'm going to flip this over to Michel, who is going to show you all kinds of good stuff that you can do with SolidWorks.
Hello everyone. I hope that everyone can hear me. So again, thank you for the nice bio there. Like it. So. Again, my name is Michel Cloutier. What I'll be doing today is showing you some of the functionality inside SolidWorks. I had maybe some key points to talk about before we really get into the subject of SolidWorks. First of all, let's just bring this up quickly. So, you know, I just jogged down a couple of notes before we launch into this seminar this morning. You know, the key points that that Lauren just highlighted about manufacturing costs. To be really honest here, there's too many people attending right now with making two different things and in so many different ways. It's hard to just tell you what will help you control your manufacturing costs. Oftentimes, you know, it's not a magic button. Oftentimes, it's more of a solution of products to help you get there, to help you control these costs. And today, we're going to talk about all of these different products. You know, SolidWorks is a product, but SolidWorks is also a company, and we offer a variety of products. And I do want to go through these products quickly. So we're going to talk about SolidWorks. We are going to talk about simulation, we are going to talk about data management, and we are going to talk about technical documentation. And just, you know, take what you see and apply it to your business. That's going to be really the easiest way to see everything. Couple key points on reducing rework on the shop floor. I put SolidWorks here because, you know, in SolidWorks you're going to be designing, doing your design. You can check for interferences, collision, basically form, fit, function. You do that all inside SolidWorks. I also put simulation because you can have, you're able to create virtual prototypes and test them on your computer rather than having to fabricate something and test them on a special testing procedure. You can all do that virtually inside SolidWorks basically. So we are going to talk about this simulation software. About minimizing costly production errors, I oftentimes go to company and they told me, well, it cost them so much money because 2 months ago the wrong revision went for fabrication. How can we use our enterprise PDM, a data management tool, to make sure that this doesn't happen? You can secure your data. Basically, you never lose a file anymore, or never overwrite something that wasn't supposed to be overwritten. And you can also control very well what gets out to your suppliers and what they have access to. And 3D Via Composer is a tool for technical documentation. So basically assembly instructions, parts manual, replacement procedures, just to make sure that everything is put together the right way every time, basically. So we are going to kind of talk about all of these throughout the presentation, and how to transition from the current software to one of these solutions. It's the ease of use. Let's not be kidding here. It has to be easy to move from one system to another one. It has to make your life easier. Not painful. So let's just start by doing some SolidWorks design. So I got an example here. So I'm going to open this up. Let couple seconds for this to get over to your end there. So basically, this is a jaws of life. The stuff that you see firefighters help people when they're in a car accident. So we're going to do some work on this guy here. Now, obviously, there is some missing components in there. If I can simply start moving some of the parts. If I hide some of them, you'll have a better understanding of how things work actually inside. So if I remove the covers here, let's zoom in. You see there's a little piston here, rod that extends, a plunger. And obviously there's some missing components right in there. And we're going to start doing these components with SolidWorks. So first things first, I'm going to start doing a new component. So I'm going to start from scratch. And I'm basically going to quickly outline the profile of the part I want to have in here. Now with SolidWorks, what's interesting is that you have different shortcuts that you can use. So for example, just by selecting this front plane here, I actually get access to a little pop-up menu that prompts me to start sketching. The other thing here I like to highlight as well is the shortcut on the keyboard. So oftentimes you can use this shortcut just to have access to what you really need at that point in time. So we're going to start by simply sketching a horizontal slot here. So I'm going to drop this in, maybe something like this. I'm going to complement this with 2 different circles, one here and one over there. And I'm going to finish off with simply lines. So also you can see that my cursor here can snap to those endpoints. I can draw horizontal, I can draw vertical very easily, so I can use all of these references. And you see here I'm actually referencing back to this endpoint here, just making sure that I'm all set. Now the other thing I want to do here is to start adding some dimension. So first of all, I do want to dimension the center to center here. So I'm simply going to drop a dimension here. This is going to be 50. Using the same dimensioning tool, what's interesting is that you can dimension a straight line. You can dimension radii. For this example here, I get a radii of 20. Notice how the tool is actually smart enough to detect radii versus diameter. So full circle is going to be dimensioned as a diameter. So I'm going to say this diameter is going to be 22. And maybe the height of this over here is going to be something like 80 or something. Make it 40. There we go. Now you can also see that I have a problem here. One of the circle has to be the same diameter as the other one. So one thing I can do here is simply window crossing here, select both of them and make them equal. So that way I don't have to add an extra dimension. And after that, basically, what I've done so far is basically do something very similar to what you could do in AutoCAD, just a 2D profile using standard 2D tools, lines, circles, and arcs. But what we do next is that we're going to take this profile here, and we're going to select this area, Control select this area, and then we're going to start thickening this into a 3D part. Now you can see here I'm actually pulling out the front face. I actually want to make this symmetric. So I'm going to pull this out, and you see the little ruler down the bottom. I can simply drop it down to 40 and make something like this. Now I'm happy with this the shape so far. I do want to add some radii at the corners here. So using my shortcut menu again, I have access to different features. So for example, I could say, okay, I want to throw a radii over here. I want to throw radii over here. One nice thing about SolidWorks too is that you always get a preview. Everything you do gives you a preview, so you know exactly what you're going to get. Let's put those radii maybe bigger, around 40. Click OK to confirm. So now I'm starting this shape here. What I do want to have here on top is that I want to open up the top here to have a slot. So I'm going to switch to a top view. And right over the face, I'm going to select the face. And again, SolidWorks is going to prompt me to start sketching on this top face using the shortcut menu. Again, I'm simply going to drop in a rectangle. And I'm going to dimension the width of this slot here to be 15. There we go. Now, as I was saying here, this is only a 2D profile. Now I want to extrude this. As I've done earlier, I can simply select the profile. Pulling outward, SolidWorks will detect that I want to add material. But if I start going the other way and pull inward, SolidWorks is going to detect I want to remove some material. So I'm going to drop this maybe to minus 40 and drop it over here. So now I actually opened up a slot. Now that's going to be difficult to manufacture, so I need to add some more fillets down here. So using the fillet command, I can simply pick an edge. You see it's way too big here by the preview. With the handles here, I can actually just type in really what I need. So I'm going to go with 2, just a small radii, pick the other edge, and confirm. Now I don't know if you've noticed, but all the time I was doing that, I didn't even, my mouse didn't even went once in the menus on top. That, I think, relates to the ease of use of SolidWorks. We try to make things, accessible so you don't have to look for everything. Again, on the bottom here, I need to have a threaded connection. So using my pop-up here, I'm going to start sketching. I'm going to sketch just a simple circle that I'm going to dimension. So this is going to be 30 diameter. Again, I need to extrude that. So I'm going to pick the edge, or the circle I should say, and simply pull on the arrow whatever dimension I need. So I'm going to need about 50 here. So I'm going to drop it to 50. There we go. Now next thing, I need to have a threaded hole in here. Using the hole wizard that comes with every sheet of SolidWorks, you have access to basically all the standards of making any type of holes. So for example, if I select this face here, you have access to counterbore, countersunk, tapped hole, pipe tap, everything you want really. Here you specified the standards. I'm going to use a metric hole. It's going to be a tapped hole, the size of the hole, and basically you just set everything that you want in here and simply position where this hole should go. So if I zoom in a bit, I'm going to simply drop this end point. So I'm going to snap it to the origin, and when that's done, I have my tapped hole done in my part. Next step, I also need to have a thread on the outside of this. So just by selecting the edge here, I'm going to insert a thread annotation on the outside here. I'm going to say this is going to be a metric. You see by default it's actually going to detect that the closest match is actually a 30 millimeter. And I want this to go up to neck, so basically all the way up to the flat face. And I'm going to confirm. Again, we have a nice preview of the thread. But getting a thread all the way up here is going to be hard to do for machining purposes. So I would typically, on the edge here, do a small machining to facilitate that. Other things you can do here with SolidWorks is that you can use library features. So basically, things that you repeat over and over again could simply be in a library. You drag and drop. SolidWorks is going to prompt you for the location of this machining feature here. I'm going simply to select the edge over here. And there's an axis on the left-hand side to one dimension, so basically the width of this. So I'm going to select maybe for, make it a little smaller, and click OK to confirm. Now this is kind of looking good so far. I do need to add a couple chamfers just to break some sharp edges. So again, using the shortcut menus, I'm going to start a chamfer on this edge here. 10 is going to be way too big, so I'm going to drop this down to 2. And I'm also going to make a chamfer all along these edges here. So you see here it propagates automatically around the part. So again, with the preview, I know exactly what I'm going to get. Just by confirming, kind of helps me determine this is what I need. By looking at this, it seems a little high. Just by selecting on it, you have access directly to all the dimensions you used earlier. So if I want to do a quick change, so basically I just want to make this a little shorter, I can just drag and drop it to the required dimension. Here we go. Looks nice. Maybe the one last thing I want to do here before I put this into an assembly is to make sure that I have the material set correctly. With SolidWorks, with every sheet of SolidWorks, you actually get a very complete library of materials. So you see here, I'm just kind of sorting through some of the materials here. So we have a lot of steels and aluminum. And all of this library is actually fully customizable. And what it does when I select a material is that not only will it assign the graphical properties like the color and everything like that, but it will also assign all the physical properties. So I can now calculate, correct weight in the center of gravity. Also can be used for simulation down the road. And like many of you, I'm sure, have your favorite shortcuts in Internet Explorer, I can actually customize this pull down here to have my favorite shortcut to make this, for example, a AISI 4340 steel component. So I'm going to save this into my my folder here. I'm going to call this a new end rod and add a small description, and I'm going to save that. Now I've done this rod here. Next step would be to make a drawing. So let's go ahead and make a drawing of this. So I'm going to create a new drawing with using a C-size template. Click OK to that. And when you create a new drawing in SolidWorks, what you quickly realize is that you have actually a view palette that pops up on the right-hand side, gives you all the views, so it makes it really easy to create anything in a drawing. You know, I want the front view, simply select, drag and drop, and once the first one is actually dropped in place, I can actually pull other views around here. So I want a bottom view, I want a right view, and I also want an isometric view. So the isometric view, I'm going to simply drop it on the lower right-hand corner here. We can zoom into this here. We can change the display. So I like my isometric view to have a little color in it, so I can do that very easily. The other thing here, when I look at this, these part here, I don't see the hidden lines. So I'm going to simply say to show make the hidden lines visible, just so makes everything a little better here. Next step, I need to reuse some of the dimensions I used earlier. So what I'm going to do here is simply run from within the shortcut menu, call in all the dimensions from the entire model, and I'm going to say OK. And basically, I get all of the dimensions I used when I modeled this part earlier. So again, saves me the time of putting all of those dimensions back into my drawing. The other thing we can do here is that using the what we call the little palette here, is that we can take one dimension and customize it so it looks really how it should. So I got two of these holes. I can change the tolerance, make it 0.1, and there we go. We have a nice little tolerance that was added. Maybe a quick cleanup here. I can pull some dimensions around. Maybe I want to flip an arrow, so I can pull this guy around. Simply flip this arrow, put it on the other side here like that. If I move into this area here, you see here I have my dimension from my radii, so I can change that and reposition it over here. So I'm just doing some very quick cleanup activities here. Delete the bottom dimensions here because they are actually a chamfer. I do want to have a chamfer dimension, so we have that in store. So basically pick two edges and drop this little chamfer dimension right there. Now, because this part was actually designed as a symmetric part, I'm missing some dimensions. So for example, the dimension from the center here to one of the holes. So I can also add those afterwards. So just by selecting the center hole and the axis of this one, I can drop this dimension and see how SolidWorks is actually smart enough to understand that if I want to put the dimension on top, it's actually going to have to push the 50 millimeter a little higher. So I'm going to do that. So my dimensions, they always stack up correctly. I can do that on the other view here. Let's move over here. Let's drop a dimension. So maybe from the front face to the center here. Oops. Drop in a 20 like this. And on the bottom here, if I remove one dimension, the other one is actually going to, get to the right place. The other thing I can do here is very quickly go and add a hole callout. So for the hole I've just machined, I just pick my edge, and SolidWorks will actually give me the full annotation for fabricating this hole on the bottom here. Other things I like to point out, so let's say my drawing is complete for now. Other things I like to point out is that you can put a lot of automation in the drawing itself. So for example, if I zoom into the tile block information here, you'll see that a lot of things actually filled in automatically. So who modeled it, and the material, the weight, name of the part. So everything is done automatically using properties. Now I want to save this this drawing, so I'm going to simply save it. As I was saying, this is a new drawing, so I'm going to call it rod end drawing. I'm going to hit save. Now what I'll need to do is to put this rod end into my assembly. So I'm going to minimize the drawing for now, and I'm going to just resize this guy here for just so we can see it clearly. And on the background here, I still have my assembly. So the easiest way to put this into an assembly is simply drag and drop. SolidWorks for years, from the beginning of its design, was actually built as a Windows native OS system. So things like drag and drop, are just a snap to do. They're fully compatible with Windows functionality. So for example, here you can see it still kind of wants to spin. So I'm going to simply pick an edge and say, okay, this edge has to be on this flat face, and confirm. So now it's kind of moving this way. There's also some components missing. So if I look over here between the arm and the rod end, there's a little part here that's missing called a link. So I need to find this part here. So I'm going to simply use the search tool right within SolidWorks again and search for anything that has a link into it. So it gives me on the right-hand side, first of all, it gives me a visual preview of the results. And also, if you look at where it's looking, it's not only looking at file name, it's actually looking at more than file name, things like description, feature names, and things like that. So I do have one part here that fits the bill. I want this from the result, the search result pane. I want this into SolidWorks. Again, a simple drag and drop, and basically this comes in place. Now I need to assemble this correctly. So I'm going to simply say, okay, well, this cylindrical face has actually to be set onto this one here. So I'm going to click OK. And by doing that, I'm actually starting to get some real-life motion out of this assembly. Again, through web, this might not kind of go through as smoothly as I'd like to, but you can actually start moving components to make sure that they have, the motion is correct. And that relates to one of the topics, about, rework on the shop floor and things like that. In a typical 2D CAD system, it would be, sometimes hard and difficult to find things like interferences and collision. With SolidWorks, if you want to find these things, it's fairly easy. So for example, I want to make sure that this is actually going to open up to the full range of motion. So I can simply move my parts here, but at a point here, it's actually going to stop. And there's actually a audible feedback on my computer. But if you zoom in closely, you can see that some of these components are actually clashing together. So what this means is that I'm not getting the full range of motion I should out of this, my plunger here. So I need to figure out what needs to be done here to have this done. But because I know exactly what's going on here, it's easy for me to, for example, go ahead and open this up here. You see there's a little machining here. So I could probably just open this up, make it 120 degrees, for example, and rebuild. So right from within the assembly, you have access to all dimensions of all the parts. So now I know that actually I do get full range of motion. So this is actually a much better design. Now I know that the motion works right, but I'm still missing some components. So I need the pins to go in there. So I'm going to simply pull out the search result pane again. And there's a pin here that I'm going to use. So I want to reuse this little guy here. So very quickly I can simply drag and drop. But when I drop it, you realize it's smaller than what what needs to be. What happens is that this pin actually has different sizes. It's all configurable. So on the on the left-hand side, I should say, there's actually a few pull-down menus I can use. So I can say, okay, I want the 22 mil diameter, and I want the 50 millimeter length. Just by doing that and clicking OK, this is actually going to resize to have the correct pin at the correct place. The other thing I need here down the bottom here will be a snap ring. Now with SolidWorks Professional comes a tool called the toolbox. So the toolbox basically is it's all the hardware that you would find that you would need in any type of design. So for example, here I can go to the metric standard. I have bearings, bolts, nuts, and washers and whatnot. I need actually a retaining ring. What type of ring? I need an external. And there's a few rings in there I can use. So I want to use the basic ring. So I'm going to simply pull this one out. And as you can see, it actually wants to resize itself. Depending on the geometry it's actually detecting, the snap ring will actually resize itself automatically to fit what's closest. So I'm going to drop this in. It actually detected that it is the 22 millimeter. So I'm going to simply confirm. And then I'm going to start to copy the pin to the other holes here. So what I can do here is simply pick the pin. I want to copy this. I also want to copy the snap ring. And where do I want this to go? Well, actually, I want this to go in this hole here, sitting on that face. And I want to do the same thing here, this hole, sitting on this face, and confirm. So quickly, I've simply copied the pins and the snap ring. So obviously here the pins need to be shorter. So I'm going to control select both of them, change the properties and make them a 22 by 40 instead of 22 by 50. Click OK. So now I have my pins. Now I need to do a symmetry, do a pattern, all of this. So I can simply use a window crossing here using the front plane. I'm simply going to say, okay, I want to mirror all of this to the other side, and click OK. And still by mirroring, I still get full motion. So if I just now bring back the cover, just to see how the finished design would look like, this would be my finished design. I can move things. I can check for interferences again. But for now, we're going to save that and simply create quickly a new drawing for this. So let's go ahead and make a new drawing, a new assembly drawing. Again, with the assembly drawings, something very similar happened to the part. I have a prompt on the right-hand side showing me all the views available. So I'm going to start by, let's just pull a front view over here. So simple drag and drop, pull the top view over here, set it over there. And I also need a isometric view. So I'm going to pull this one right over here. So for the isometric view, what I want to do here is, first of all, I like colors again in my isometric view. The other thing is that I can ask this to be an exploded view. So if I explode this, we can see now that there was actually an exploded view that was done prior, but there are some changes that need to be done here. The new arm is not set correctly. So I'm going to simply go back to my assembly, and we're going to put the exploded view on top. Now I want to reorganize or rearrange this exploded view. So I'm going to window select these components. And it's very easy, really. You just select components and you pick on the arrow on the screen, start pulling outwards. I'm going to take the 4 pins here, pull those 4 pins up, take the 2 links, pull them in front, maybe over here, take my rod end, maybe put it over there, and window select all my washers, move my washers a little further down. So very quickly I was able to reorganize my exploded view. What's also neat here is that all of these exploded views can be animated. So again, might not go as as smoothly over the web, but these can be animated fairly easily, and the animation can also be recorded, saved as an AVI. So if you need to show that to someone, very easy to do so. So let's go back to my drawing. And basically what you'll see is that my exploded view is simply updated according to the position I've created in my assembly using this explode view. Now to complete this drawing, I'm going to need a bill of material, so I can simply move this view a little over here. I'm going to say I want to pull down create a bill of material. I'm going to click OK to that. And what's also nice is that everything is accounted for. Quantities, numbers, description, everything is in there. The last thing I would need to do here is to balloon everything, have an item balloon to everything. Well, if you want to do that quickly, you can simply use the auto balloon function. Kind of tug this in a little bit here. Click OK. So I'm going to confirm. Other thing I want to do in this drawing before we leave for something else is to show that this jaws of life in the open position. And we can do that right within here too. So I'm going to say I want to create an alternate position. So I want to show this open and close. And what's nice by doing this showing open and close option here is that you can also dimension to anything. So for example, I could dimension from one end here to the other hand right over here. Oh, let me just do that again. So I'm going to dimension from here, let's say to this end here. Drop a dimension, but you can also dimension directly to the other position as well. So I want to show how wide the the jaws of life can open, so I can show that right in there too. So now that I've done this assembly drawing, let's just save it again, and I'm going to simply say it's a spreader assembly drawing, and I hit the save button. There we go. So now that I know that some of you do prototypes and things like that, we're going to see how we can use that and create some of those in SolidWorks. If I look at this assembly, before we go into that, I want to talk briefly about data management. If I pull on the right-hand side here, I actually have a view of all the components and their stages, who's working on them, what's doing what. And a couple of things that appear clear to me is that some of the things highlighted in green basically means that they are newer than the saved copy on the vault, and those are actually the ones I'm working on. But there's a handle here that actually is in red, so that means that it's actually older. The one I have on my computer that you see here, the rounded handle here, is actually older than the one that is on the server. So what is that? Why is that? Well, that could be one method when multiple people working on different projects or working on the same project, I should say. So basically, what happened while I was working on this assembly, someone was working on the handle assembly, and there's actually a quick comment here saying that it was too complicated to manufacture. So they've decided to change the design based on cost. Now, it's kind of our job to, my job here, to make sure that this still works right in my assembly. First thing I want to do, though, is that I do want to update this drawing. So how I can do that, very simple. I can simply say right-click and get latest version. So that's going to actually pull the latest version from the server, and it's going to automatically update my drawings, my assembly, and everything that goes along with it. So within a couple of seconds here, you can see that the new handle has actually been replaced in my assembly. It's also been replaced in the drawing itself. But as I was saying, we need to make sure that this works right. So I'm going to simply to open this up and talk a bit about simulation. So I know this is actually subjected to some stresses, some forces. I want to make sure it's not going to break. So I'm going to start a new study. You can see here on the left-hand side, there's multiple types of studies we can do within SolidWorks. So I'm going to just do a plain static study for now. And now actually Enterprise prompts me saying, hey, you're about to change this file. You should actually take ownership or check it out. So I'm going to do that. And back to simulation here, I'm going to simulate how this is actually going to be fixed in the assembly. So by doing this quickly, I simply go ahead on the screen, and I'm going to specify that these 4 holes down the bottom here are actually fixed. So basically, they are not moving. Once this is done, I'm going to simply apply a force. I'm going to apply a force on the top cylindrical face, but it has to be pushed in a certain direction. So in order to do that, I'm simply going to say, okay, I'm pushing this way. It's going to be, let's go in newtons. So it's going to be 500 newtons on the other side. And the visual feedback is awesome. You can actually see that the arrows are pushing in that exact direction. So I'm going to simply hit apply, and basically we're going to run the simulation and let it go. So basically what it's doing now is that it's solving the problem for me. So rather than me having to fabricate something and test it out, on a special fixture or something like that, I can have actually SolidWorks do that for me. And very quickly I get some results here. So first of all, I get some stress value. So you can see the values up on the right-hand side here. So I got stresses, close to 50,000 psi. I can animate this again. Again, this might not go as smoothly over the web as in real life, but you can easily animate this. So I know that I have a high stress, but really what I'm looking for is a factor of safety. And we do have that in the results. So right now my factor of safety is 1.4. I'd like the factor of safety to be higher than 1.4, and I'm shooting for at least 2. So I'm going to simply create a new plot here, and I'm going to look for areas where the factor of safety is below 2. So these would highlight very quickly the critical areas. If I zoom in, I can realize fairly quickly that some of the critical areas are right around the holes down here. So I need to do something about that. Again, because we're nicely integrated inside SolidWorks, I can simply go to SolidWorks and simply change the dimension, maybe make it 8 or something like that. So I've basically thickened the base plate for this. And when I'm done, I'm simply go ahead and rerun the study just to make sure that my changes actually affected something. So again, a couple seconds here to run the simulation. And by doing that, it's also going to update all the results. So the first result we've shown earlier is actually the stress. So I dropped down from 50 to 28,000 psi. My factor of safety now, it's all blue. But my factor of safety now is actually 2.4, which is good. Other things you can look for is for displacement. So I'm curious to see how this will bend under the actual usage. So I know that it's going to bend 0.09 inches. So it's a great way to make sure that things don't fail when the people start using it in real life. Another method, I think, to help with the reduce rework on the shop floor and things like that. So this is good. I like this design. I'm going to flip back to my drawing just to make sure that this drawing is updated. And as you would probably imagine, it is updated. If we zoom in closely and we just pull a quick measure off of this edge, you'll see that the length of the edge is 8, so everything was updated accordingly. So for now, I'm kind of done here with this, all of this, these drawings and everything. So I'm going to simply quit and save all. And now we're going to talk briefly again about data management. So I'm going to minimize this, and I'm going to expand another window just to give you a quick look into my vault. The vault is actually the secured area where all the files are stored. Depending on your level of access, you can do different things. And very easily, the vault is very easily set up just as Windows Explorer. So basically, there's actually a blue icon that indicates you're in a vault. You got all your files. You can set your files as you want. What's kind of nice about Enterprise PDM is that without even having SolidWorks installed on your computer, you have access to a full 3D preview of all your SolidWorks models. You could actually explode an assembly right within the bottom head and pick a dimension. So a tool that's very easy to use. Now the preview is good for viewing and previewing SolidWorks files, AutoCAD files, all those type of CAD files. It can also preview things like Word documents. So if you have a Word document, and actually I do have one here that actually talks about the instructions. If I go down here, you'll see that some of the images here of this instruction manual are outdated. You see here the handle is actually curved. I need to replace that. So a bunch of information. If I go back to this assembly, I have also a data card, so basically information about the file. I can see just by hitting a button here, I can see the full bill of material. I can see what's in it and where this is actually used. So this is actually interesting. I can actually tie other types of documents with my SolidWorks file. So for example, I got this assembly that's tied to another document. That's my instructions. That's actually a 3D via Composer document. We're going to talk about that later. And that's tied to a Word document. So basically, I'm using 3D via Composer to create the images I'm going to set into this Word document. Good. So now that we know that some of you do some type of documentation, oftentimes what I see is that a product like this would actually get fabricated, manufactured, and then people put a lot of images mixed and mashed with a lot of text like this. Now that's not bad. The problem is, you actually have to have something built in order to create those manuals. In this case, we're going to use 3D via Composer to create those images, high-quality images, and then put them in my Word document. So I'm going to close the Word document for now and go over here and open up my 3D via Composer document. So as I was saying, 3D via Composer is a tool that helps you create all of those technical documentation. So for example here, I got my assembly. You can see over here. Also, what you realize is that how to get this in is actually fairly easy. Simply file open, and then you drill down to the SolidWorks parts or assembly. So you simply import your SolidWorks assembly over here, and from then on you can start creating any type of images that you would need later on into a technical documentation. So we're actually going to do one right now. Before we do that, if we flip to some of the views here, you see these are the images I used originally in my, my Word document. Now I need to update these. Fairly easily, I've created some images. I don't want to lose everything, so I'm simply going to select this handrail assembly, and I'm going to say, okay, I want to update it, and I'm going to simply browse to my new version. And I'm going to say, okay, I want to update it with this guy here. And then say simply update. So this is actually going to launch a conversion. So it's going to read in the new part, and it's actually going to replace it right inside 3D via Composer. Now what's nice is that I didn't lose any of my prior work I've done before. So if I go back to any of the views here, basically what we've done is simply we swapped out the old geometry for the new one. So you see here the image number 2 has the new handle assembly. If I go to image number 3, again I have the new handle assembly, and that goes on for all of the different views I use. Now I showed you how to update all of these. That's nice. Let's do one from scratch. So I want to show here in my Word document, I want to add an image showing how to replace the batteries. In the handle here, you can see there's actually 2 little LED lights. And on the back here, there's actually a cover with screws, and that's where the battery goes. So what I'll do here is simply going on the screen, I'm going to Control Select, pick both of these screws, and then start pulling them away. So I'm going to pull this one out. I'm going to pull the cover. I'm going to pull the rubber seal, and then I'm going to pull out the battery. Now, so far, something like that you would be able to do inside SolidWorks. What really is the difference here with 3D via Composer is that you can, first of all, you can change the way things are showing on the screen much easier. So, for example, I'm going to switch to a custom mode. And because I want to highlight only the components on top, one thing I could do here is simply window select all of these components, and make all of them in a silhouette edge mode. And then I could actually take all the ones on top here, take all the ones on top here and make them solid with an outline. So you see here, I can very easily match this type of illustration. The other thing that's, well, close to impossible to do inside SolidWorks is to add some more annotation, things like arrows. So again, arrow here. I want to point out that this has to actually come out this way. So I can simply use my arrow, drop this arrow just like this. I'm going to put another one here, drop it like that. So I got my two arrows right here. Whoops, I missed one. So let's drop this one here. There we go. Maybe the arrows are a little pale, so I'm going to bump up the transparency, make it really opaque. I want to make them thicker, so I'm going to hit the 3. I want to move them as well. So using my control here, I can actually pull them backwards like this. The other thing I see here is that my arrows are actually sitting on top of the parts, hiding some of them. So what I can do here is disable the stay on top. So basically the arrows now are coming through the components. Makes things a lot nicer. Other things we can add are things like circular arrows. So for example, I want to snap a circular arrow to this edge here. Let's put another one to this one here. So I got my 2 circular arrows. I can, just as I've done earlier, I can pump up the transparency, make the size different. I can also make them roll on top. I can change the radii or the angle of it. So I can play with these arrows very easily, and again bump up maybe the size of this. So now that I have this view here, I want to save it. So I'm going to simply create a new view, and we're going to call this battery change. So I got this view here inside Composer. The next step would be to save out this view to an image, take the image, put it into my Word document. But I have probably 10 different images here. I don't want to do those one by one. So right out of the panel here, I'm going to say I want a high-res image. I want to save all of these, and there's some preset settings here you can save. But basically, I want to save all of them together, so I'm going to simply say Save As, and save those where my folder containing the old images are, and basically overwrite everything that's in there. So yeah, I want to replace everything. So all the new images are now created. If I open up my new drawing, because the images were actually linked, you see just by opening up my new Word document, all my Word document is now updated with all the new images. So now I would basically be ready just to reprint this manual and go ahead with it. So we talked about a lot of different things. I tried to kind of give you an overview of all the different tools. Again, SolidWorks is the CAD tool, but there's many different parts that could apply to different people. Simulation if you want to do virtual prototypes. Spares view, important mistakes or field failures that could be really expensive. Enterprise PDM is the tool I use basically just to manage everything, just to make sure that I'm on the right revision control. If there's multiple people, on the team working on the same design, some people might be working on some areas, others on other areas, so you can share much easier. And also 3D via Composer for the technical documentation. Everything that needs to be printed or any type of animation, assembly instructions. I use the instruction here, but it could take different forms, HTML, kind of web-based, AVI, things like that. There's many types of documentation can be used.